Hi everyone, welcome to Smart Sterile, where we talk about everything from sterilization to innovation in healthcare. I'm your host, Vanessa, and today we're going to be diving into something that costs hospitals big money every year: the high cost of repairing robotic surgical instruments. We all know technology has changed the operating room, but behind those high-tech robotic arms are some very real challenges from hospitals and the sterile processing department. Today, I'll break down why these instruments are so expensive, how repair costs affect hospitals, what roles sterile processing techs play in the problem, and most importantly, how can we fix it? All right, let's get started. Robotic surgery has completely transformed healthcare. Systems like the Da Vinci surgical robot or ROSO robot lets surgeons perform incredibly precise, minimally invasive operations. But that comes with a price. Each robotic instrument, things like Maryland bipolar forceps or needle drivers, is built with tiny joints, electrical contacts, and sensors. One tool that can cost anywhere from $2,000 to $3,500, and it's only approved for 10 uses before the software locks it out. So hospitals aren't just buying the robot, they're constantly buying, repairing, and replacing these tools, adding in shipping costs, vendor contracts, and downtime when an instrument is out for repair, and the expenses skyrocket. When you think about how many robotic surgeries happen daily, sometimes 10 or more, you can see how fast those costs pile up. In this segment, we're going to show how repair costs impact hospital budgets. Surgical services bring in revenue, but they also are one of the biggest cost centers in healthcare. If a robotic grasper that costs $3,000 breaks after 5 uses instead of 10, that's $1,500 wasted. Multiply that by every operating room in the hospital, and you're taking tens of thousands of dollars every month. A healthcare purchasing news article reported that robotic instruments repair can make up to 30% of a hospital's total surgical tool budget. And here's the frustrating part: many of those costs are avoidable. Instruments dropped, improperly cleaned, or mishandled during transport. So that's where the sterile processing department comes in. Where sterile processing fits into the problem. Robotic instruments aren't like your standard clamps or scissors. They're very delicate. They have wires, gears, and fiber optics inside. That means they need extra careful cleaning, inspection, and handling. If a sterile processing tech uses the wrong brush or too much pressure, they might bend a wire. If they submerge a power tool, the electronics can short out, and if the contacts aren't dried properly, corrosion will start to set in. And just like that, there's another $3,000 repair bill. So manufacturers like Intuitive Surgical actually require facilities to follow specific instructions for use, and even recommend special training for sterile processing staff. So when we skip steps or rush the process, the risk of damage and cost goes way up. Our work directly affects how long these instruments last and how safe they are for the next patient. So how do we fix it? Here are some proven strategies hospitals use. Number 1, specialized training. Vendor-led workshops where sterile processing techs get hands-on experience cleaning and assembling robotic tools. When techs see how sensitive those joints and sensors are, they handle with care. Preventative maintenance. Instead of waiting for someone to break, schedule regular inspections. Biomedical teams can spot small wear and tear issues before they become major issues. Tracking instrument usage. Use tracking software to count each use and retire instruments before they fail. Delicate handling zones. Create padded, clearly labeled areas for robotic tools only. No mixing with trays or crowded counters. All these steps do not only save money, they build pride and professionalism in the sterile processing department. One hospital in Florida saved $40,000 a year just by doing weekly inspections on their robotic tools and retraining staff. Their breakage rate dropped by 25%, which that's pretty amazing. Another facility in California applied Lean Six Sigma to map every step of their robotic instrument flow, from decontam to sterilization. They discovered that damage happened during transport. By switching to padded trays and better labeling, they cut their costs dramatically. Little changes like that make a huge difference when everyone works together as a team. So, what's the takeaway? Robotic surgery is incredible. It's the future of medicine, but those fancy instruments come with high repair costs that strain hospital budgets. The good news is sterile processing techs can be part of the solution. With the right training, preventative maintenance, and smarter tracking, hospitals can save thousands every year and patients stay safe. Every instrument we handle is part of a bigger system. Our attention to detail protects budgets, teams, and lives. Thank you so much for listening to Smart Sterile. Until next time, I'm Vanessa Rodriguez, reminding you to always keep it clean, keep it smart, and keep it sterile. Thank you.